So do you want
Hey, welcome back. This is a continuation of our series with Professor Jeremy Baumberg. To fully understand this video, we've done a little pre-video, if you can call it that. When electrons orbit a nucleus, we can think of them as standing waves. The energy of a standing wave is determined by its wavelength. Smaller wavelength equals higher energy. Jeremy explains this in more detail. We usually think of energy as being a kind of continuous thing, but quantum mechanics kind of suggests that there are energy levels or discrete states in which certain particles can have certain amounts of energy. Why is that the case?
Yeah, it's interesting. Let's imagine an electron, which is actually still quite a mysterious particle. We know it has a mass and a charge, but actually it's infinitesimally small for us. But actually, it still has a continuous energy spectrum. If we have a huge room, and we just have an electron moving in it, we can have it moving at different speeds, and it has a kinetic energy, and it can be a continuous spectrum. We can give it whatever speed we want. But if instead we put it near a charge, like a positive charge in an atom, so it tends to want to orbit around it. It's attracted to the center of the atom. And then we start to see some of the wave-like properties. So because it's a wave, as it orbits, it can oscillate a certain number of times before it comes back to the start. So if it oscillates once as it comes back to the start, that will be different if it oscillates twice. So if it oscillates once, there'll be a certain wavelength associated with it. That means there's a certain speed associated with it, which means there's a certain energy. If it oscillates twice, there'll be a different energy, a different wavelength. So what that means is that when the electron is actually confined in a certain region of space, then it tends to have only certain discrete energies that it can take. And there's a whole range of them. They tend to from a ground state energy up to higher energies. And those energies are really important for what we see from atoms, that they emit light of particular colours.
Thank you so much for watching. Like and subscribe to keep up to date with our latest videos. We'll have new releases every Wednesday and Sunday, so look out and I'll see you guys soon.